Hello everybody, welcome back to my YouTube channel and welcome back to yet another exciting experiment with Snowflake. This evening we're going to focus on DevOps. Yes, you're right, DevOps with Snowflake. Before we get started with the actual content, here is a gentle request. If you are new to this channel and have not subscribed to it, please consider subscribing. This tiny gesture from your end may not cost a lot of time. However, for content creators like us, it means a lot. Would also request you to hit the bell icon. This will help you to stay updated with all the latest and greatest contents that I keep bringing it to you through this channel. And finally, a quick disclaimer. All the ideas and thoughts that I bring to you through this channel are absolutely mine and they have no connection with my employer. Great, let's begin. Wait, forgot to tell you something. This video is going to be close to 45 minutes, but it's going to be very exciting. So please ensure that you stay put and watch till the end. Let us start focusing on this article. This article talks about continuous deployment with Snowflake-CLI and GitHub Actions. Before we start talking about Snowflake-CLI and GitHub Actions, let's talk about continuous deployment. Continuous deployment is a subpart to the entire DevOps lifecycle. DevOps primarily has two components. First, continuous integration, and second, continuous deployment. If I double click on continuous integration, I can further break it down into three parts. That is the build part, the test, and the merge. These three parts primarily focuses on the software build part of it. Once continuous integration is over, the code is ready to be deployed. We can deploy that bundled code to production. And that is the process of continuous deployment. Whether we are building a data warehouse, a data application, or maybe an AI application in Snowflake, if you are a part of the engineering team, you should always focus on building a solid continuous deployment pipeline. Because if your continuous deployment pipeline is not strong enough, you will not be able to ship your product quickly and efficiently to production. Now, to demonstrate the power of continuous deployment with Snowflake-CLI on Snowflake, we have taken a sample scenario. In our sample scenario, we are building a data application with Streamlit and deploying that on Snowpark Container Services. Now, Snowpark Container Services has recently been launched, and since then it has been a favorite choice for all the Snowflake developers in the industry. You can bring in any code of your choice and host it in Snowflake Container Services. In our sample scenario, we will be using Snowflake-CLI commands from GitHub Actions runner and try to deploy our Streamlit app on Snowpark Container Services. Now, this is not the first time we are talking about DevOps on Snowflake. However, in the past, we had SnowSQL. Now, SnowSQL allowed us to execute SQL commands from the runner to manage Snowflake objects. When I talk about runner, I am talking about GitHub Actions runner to manage Snowflake objects. Let us focus on the Snowflake-CLI. Now, the Snowflake-CLI is a command line client that primarily focuses on managing workloads and applications that connect to Snowflake by using CLI commands. Here is a quick snippet that shows how you can use the Snowflake-CLI. Here in our case, we are not using a self-hosted runner. And because we are not using a self-hosted runner, we have to install the Snowflake-CLI every time the runner is invoked. And once the runner is invoked, we can test the version of the CLI that is getting installed. What is the tech stack that we are using? We are using GitHub repository as our code repository. We are using GitHub Actions for our continuous development workflow. And finally, the application is getting installed on Snowflake Container Services. Let's look at the GitHub repository once. On the left hand side, first you have the docker image.yml, which is nothing but the GitHub Actions workflow. Down below you have the Docker file, and within setup you have a setup.sql, which is a bunch of SQL statements which prepares your database before the Docker image is shipped to container registry. Here is the spec.yml. This is nothing but the definition of the Snowpark Container Services service that we create. We will look at all those code in detail. And here is this very simple and basic Streamlit application that we are deploying. Config.tml, this is the file that is used by your Snowflake-CLI. We have looked at most of the important artifacts of our repository. But before we dive and double click on each of those important files, let's go back a little bit and look at the documentation for SnowSQL and SnowCLI. Now this will give us a fair understanding about how different they are and what additional benefit that Snowflake-CLI brings to the table. Let's look at SnowSQL first. I'll straight away take you to SnowSQL usage. Over here, if you see, SnowSQL is primarily a way to talk to Snowflake by using SQL commands. Are there any examples? I'm sure there will be. As you can see, using the SnowCLI, you can, using the SnowSQL, you can fire a SQL statement. You can pass on a SQL file, SnowSQL-a, your account parameters, and then the file name. And that's all. So that means you can always bundle a group of SQL statements within a file and use that file to talk to Snowflake. Now, that's one way of talking to Snowflake. However, that may not be the efficient way because you have to write a lot of code. Think about a scenario wherein you have certain commands to talk to your Snowflake objects. Here comes Snowflake-CLI. There are a bunch of steps which shows how you can install the CLI. Now, I'm not going to go through in detail. You can review that if you want. This helps you to install the Snowflake-CLI on your local machine. Now, if I go to Container Services, you can see how can you manage your compute. Here is a command with which you can manage your compute. Snow SPCS compute create pool, right? If you have to suspend your compute, this is how you do it. If you have to resume, and this is how you do it. So the beauty is there are commands with which you can communicate with your Snowflake objects, and you are no longer dependent on just SQL statements. Let's go back. Before I go and talk about this code, I think we need to go to our repository. Here is our repository. Let's start from the top. Here is the docker image.yml. If you look here, we are starting with reading a bunch of environmental variables. Then we are doing a Docker login, and once the Docker login is successful, we are doing a Docker build. Docker build of what? Docker build from the Docker file. Let's go ahead and look at the Docker file. What is the Docker file doing? The Docker file is copying the Streamlit folder and the requirements.txt folder. It is installing the requirement.txt and finally initiating the Streamlit app. Let's look at the app. It's a very simple app. It just uses Streamlit options menu, creates an option on the left hand side, and it just prints this is a simple app. Nothing fancy, however, it is enough to give you an idea about how to deploy your app on Snowpark Container Services using Snow-CLI. Let's go back to Docker images. This is where you are building the image. Once the image is built, it is time to install Snowflake-CLI. Once the Snowflake-CLI is installed, we are going ahead and testing if the connection is successful or not. Now, if you see, at the time of testing the connection, I'm using account admin and research as my warehouse and role. Soon after that, I'm using a SQL script to prepare the database. Let's go ahead and look at the SQL script to understand it better. So what am I doing? I'm creating a database. I am creating a role, and then I'm transferring the ownership of this database to the newly created role. I'm creating a new warehouse, creating a security integration, and binding the service endpoint to the role that I just created. Now, these are steps that are very, very specific to creating Snowpark Container Services. If you are new to Snowpark Container Services, I would sincerely request you to go ahead and look at the documentation for Snowpark Container Services, and there are 4 or 5 tutorials, very simple, easygoing tutorial that will help you to understand all these steps in detail. Finally, we are using this SQL to create the compute pool. Now, I could have used Snow-CLI command to create the compute pool as well, but just to keep it a mix of Snow-CLI command and SQL, I'm using this create compute pool command to create the compute pool here. Once the create compute pool command is successful, we are granting usage and monitor on the compute pool to tutorial CI/CD role. Line number 29 to 40, this is an anonymous block wherein I am finding out my current user and assigning the CI/CD role to the logged in current user. Line number 42 to 48, I'm just finding out if the service that I'm going to create using my service or spec.yml, if it exists. If that particular service exists, then I'm dropping the service. Let's go back to my YML file. Now, once this script is successfully executed in this particular command, setup.snowsql connection is dummy out here. That means I am no longer going to use the role account admin or the warehouse research. Now is the time for me to use the newly created role, the new warehouse, the new database, and the schema, and that's exactly what I'm doing. I'm overriding role, warehouse, and database environmental variables with new value. Once done, I have to do a bunch of steps. The first thing is I'm going to try connecting to my Snowflake new database using Snow connection test and the new connection parameters. Once successful, I have to create the image repository, and this is how you create the image repository. Snow SPCS image repository, create tutorial CI/CD repo. Image repository is nothing but a place to host your image. Now if you remember, we had already created the Docker image on the top. It is time for us to tag the Docker image appropriately and then push the Docker image to the image repository that we just created, and that's exactly what we are doing. We are tagging the Docker image, we're looking at the available Docker images, we're logging in to the image registry that we just created, and finally we are doing a Docker push. Now don't be worried about from these statements, line number 58 to 65. These are all nicely documented in the Snowflake documentation. Kindly take a look at it, or maybe I can take you there as well. So if you go to Snowflake-CLI, manage compute pools, if you go to manage services, you're going to see those commands. Create the service out here. You can suspend the sub-service, you can get a status of the service, and you can also list all the endpoints. Okay, let's go back. Now these steps need to be executed in order and you cannot change them. So first you have to create the image registry, you have to push the Docker image, and finally create the service. This is where the service is getting created. Now please remember, once you create the service, it takes some time for the service to come up. And even once the service status shows that the service is ready, it takes another minute for the service URL to be populated. And that is the reason I've put a sleep for 120 seconds. If I wait for 120 seconds, I have seen that I can successfully get the service status and as well as the service endpoint. Once the sleep for 120 seconds is complete, I'm going to reinitiate a connection, and this time I'm going to get the status of the service and I'm going to get the service endpoints. This entire script has been shared on the Medium article. We can look at this screenshot for a while, but let's do something. Let's not waste time looking at this screenshot, because if you are watching this video, I think it makes sense to see the entire process live in action rather than looking at this screenshot. Let's go back, and I'm going to make a commit, because if you see, it's on push. So the moment I push it to the main branch, this entire script is going to rerun, right? So let me go to workflows, YML. Let me try to edit it. Maybe I'll just put a small space bar and I'm going to commit it. Let's see. Let's go to actions. This is the latest action that we just triggered. Let's open build. Let's see what is happening. Okay. The Docker image build process has already started. Let me go to Docker login. Docker login was successful. Running a command. Yes, I was able to run a sample command. Docker build image is in progress. It takes a little bit of time. I think the image size is around 1.5 GB. So it's going to build an image for 1.5 GB and then it is going to push that 1.5 GB to Snowpark container services. Okay, the image building is done. Now it has already installed Snowflake-CLI on the runner. Test version is successful. test connection using account admin and research is also successful. Now it is preparing the database by executing setup.sql, which we just saw. I think everything is successful. Finally, it is creating the image registry and pushing the Docker image. What is it doing right now? I can see that there is an image called Streamlit app, and I see the size is 1.5 GB. After it has tagged itself, the size is again 1.56 GB. It is pushing this image to Snowpark Container Services. This process of pushing the image from the runner to Snowpark Container Services, or to be precise, to your image registry, it takes a little bit of time. It depends on the bandwidth available, because it's going to push 1.5 GB of data, right? Now, just to make you aware of what we are trying to do, we're going to deploy it. We will wait for the service to come up, and we will log into Snowpark Container Services and see the app in action. Once we are satisfied that okay, the app has deployed correctly and we can access the app, we will go ahead and make a small change to the application code, and we will try to deploy it again, and you will see how fast and efficiently this entire change is pushed to Container Services again, and you will be able to see the changed code live in action. Okay, so the create registry, this piece is working. In my experience, whenever I ran it in the past, it took around 5.5 minutes to 6 minutes to complete the entire process. Now please remember, there's already a sleep of 120 seconds, so 2 minutes is something which I'm spending to wait for the service endpoint to come up. Unfortunately, there is no conditional check that I have put. I think if the service size increases, or maybe the number of services which you are creating in a particular compute pool increases, it might take a longer time for all the endpoints to pop up. In that case, you might have to increase 120 seconds to maybe 300 seconds. Now at this point of time, Snowflake-CLI doesn't provide any conditional statement with which you can wait till the time the endpoint comes up. Maybe such a command might come up in future, but as of now you just have to anticipate the amount of time that it might take for the endpoint to come up, and then put a sleep accordingly. We're still waiting for the image registry. A lot of the layers have already been pushed. This is preparing and this is waiting. Depends a lot on the available bandwidth of your network. Okay, Streamlit service Streamlit successfully created. This is the message that you will get once the image has already been pushed, right? Now at this point of time, if you can log into your Snow site and if you go ahead and query your image repository, I'm sure you will be able to get the image details, right? So let's wait for 120 seconds and we should be able to get the status of the image or the status of the service created and the endpoint. If I go back to my Snow site on that particular account, if I run this, use role CI/CD, and if I go to show image repositories, what do I see? I can see the image repository, and if I want to see the image, I should be able to see the image Streamlit app, right? So the image has been uploaded, the service has been created. If I say show services, the service has been created. However, the endpoint takes a little bit of time, and that's what we are waiting for. Cool. If you see, I'm getting the service status and it says running, right? And then I am firing show endpoints, and this is what the endpoint of the service is. So I need to copy this endpoint. Let's go ahead and check it out ourselves. There's a little bit of formatting that is required on the endpoint that comes up, and let me click it. Let me sign in. And I see the app. Fantastic. This is a sample app. There's nothing much on the left hand side. All it says this is a sample app and this is a sample menu. Great. Now let me close this. I'll go back to my Streamlit code and I'm going to make some changes. Now before I do changes on my Streamlit code, there's something which I think I did not talk about. Let me open config.toml. Now this is the file which has all the connectivity details that are required for your Snow CLI to connect to Snowflake. Now here if you see, I did not put the username and passwords here. I've just put test, test and test. And if I go back to my Docker YML page, you will see that I am overriding all the information which are provided in the config.toml with your environmental variables. And how am I doing it? So every time I make a connection, Snow connection, I'm passing the connection name as dummy, which is nothing but the connection which is there in config.toml. Now if you are new to Snowflake CLI, I would request you to go back to the documentation and check it out. What it says, if you are willing to override any information which comes from config.toml, you will have to just put that information as an environmental variable on your runner. Anything that comes from config.toml will be overwritten by these environmental variables. Okay, so let's go back to my app.py I'm going to do an edit and let me add another sentence. This is an updated version. Okay. Now the moment I commit this, the second execution of the runner is going to start. Now this time I'm not going to make you wait for another 7 minutes. I'm going to commit this, let it start, and I'm going to pause the video and come back once I see that it has finished. So I'm going to go here. It has just started. Yep, the Docker build phase has started, and I'm going to pause the video out here and come back once I see that the endpoints are available. Okay. At this point of time, I can see that the image registry has been created. The image has been pushed. The service has been created as well, and it is sleeping at this point of time and waiting for the endpoints to be provisioned. It's been more than a minute, so I think it should be done very soon. Now at this point of time, you can really understand the benefits of continuous deployment, right? You just made some changes to your app. You are sure that, yeah, that's the change that you want to implement, and you just committed to the main branch. The moment you commit, the entire process takes close to 5 to 6 minutes, and your updated code is deployed on your production server. Had it not been the case for this CI/CD, what would you have done? You would have gone to Snow side, you would have triggered a bunch of SQL statements, one after the other, and that would have taken maybe the same amount of time, 4 to 5 minutes, or maybe a little more than that, but they were all prone to errors, and you had to log in to your production server to do that. Now the benefit of here is you don't need to log in. You have written your scripts, you have given all the credentials, and the continuous deployment process, GitHub Actions, takes care of everything in the background. Cool. Let's take this ingress URL again. Let me go back. This is something which you have to pay attention to while you are copying the URL, because you're copying from the command line and it doesn't give you a very nice experience to copy, to be fair. Now you can go to Snowflake-CLI or maybe your Snow site and copy it from there, but if you copy it from your GitHub Actions command line, you'll have to be a little careful about your URL. Now you see how quickly we were able to deploy the updated version of the app, which talks about this is an updated version, on Snowflake Container Services. Cool. Thank you for being a lovely audience. And at this point of time, if you think that this has really benefited you, please consider hitting the like button. All the code that you have just seen are available in the GitHub repository, and the link for the GitHub repository have been shared in the description box. Thank you very much once again, and we will see again in the next lecture. Bye-bye.